Welcome back, everyone, to Enterprise Security Weekly. Quick announcement, come check out Wild West Hackin' Fest, put on by Red Team specialists from Black Hills Information Security. Join us on October 27th and 28th for hands-on hardware hacking talks by famous InfoSecers like Dave Kennedy, Deviant, Egypt, Chris Nickerson, Chris Gates, Mike Poor, Sub T, and more. Check them out at wildwesthackinfest.com. That's hacking without the G. Now, I want to turn it over to Apollo Clark. Talk about managing AWS cloud resources, something that if you're an enterprise and deploying to the cloud, you're going to have to deal with.
So I'd like to start with a really good quote from one of my good friends, Andy Sutcliffe, a security engineer. Every good sales pitch involves triangles, either facing up or down. You've seen it. We've seen so many sales pitches. Let us show you the triangle of success.
Yes.
Or the funnel of success.
Yes.
So,
they love the pyramid.
The pyramid.
The pyramid.
The pyramid
yes.
of success. Let's start with the pyramid. If you're managing resources, let's for a second ignore AWS, but this applies to AWS obviously too. Mm-hmm. You need to do inventory management. If you don't know what you have for resources, you can't defend it. You can't. Right. You need to know the lay of the land because hackers and pen testers, John Strand, et cetera, they're opportunistic. They're going to find the oldest, crustiest, least secure, default password-ridden system they can possibly find anywhere on your network to get a foothold.
Yep.
So if you're not doing inventory management and having a sense of what everything is out there, then you're going to miss something. So that's number one. Number two is doing resource state management, which is a little bit different. Inventory management is knowing what you have. Resource state management is ensuring that it's configured the way it should be. Mm-hmm. Because, as companies evolve and change, the configuration of these things will change over time. And you got to make sure that the configuration does not change to be insecure or in a way that you did not expect it to be.
Right.
Next up is, good old favorites. Default, weak, reused passwords. Because if you're going to be a hacker, just walk in the front door. And shared accounts. Because that's the Achilles heel. Shared accounts, you can pivot through the whole system. Now, once you have those, then you can start doing a little more interesting things. Next up is upgrading old components. Because, you may have the newest, fanciest thing for your core product, but if you have that old, crufty system, that's going to be what's going to get attacked.
So back up to default passwords, because in not cloud environments, I find, and there are some solutions out there, but I find in large part, it's hard to go on your network and discover everything that has a default password. Yeah,
so I thought about that problem a little bit too. I mean, I mostly do web apps.
I think you and I might be the only ones that spend a significant amount of time because when I Google search it, I find my own blog post, dude.
Yeah, that's the fun part. Yeah. I mean, I do web apps, so I use Medusa. Mm-hmm. Medusa, Hydra, I use John the Ripper. Yep. I use the Rock U, 1 million default password kind of thing. That's my go-to.
Okay.
So what I'll do is I'll do DNS enumeration, give me all the DNS names. So I do resource inventory first, do DNS recon, then I'll brute force. I'll usually use OWASP Zap and just get all the I'll brute force through all of the URLs, and then I'll try and find the login ones, admin, login, user, et cetera, et cetera. Then I'll try and find the default usernames, admin, root, et cetera. Then I'll just brute force with the default passwords. So that's a way of doing it. Again, that's more web focused, but you could apply the same technique to things like Active Directory, SSH, FTP, et cetera, et cetera.
What I find difficult is when you get into SSH and FTP is it might be a small device that, or even an application that might fall over if you brute force it.
You got to be slow and low.
You're either going to be slow and low, or you got to fingerprint that device and just try a smaller subset.
Yeah.
And that connection, those connections, don't exist in. If anyone has technology that does that, please let us know. I know there's a couple of things out there that I have yet to research that people have told me about. After I've presented live somewhere, people have mentioned things and I forgot to write them down. I know there's stuff out there that may exist to help with that problem largely. Now, solving that in the cloud, is that easier?
I would argue, it's a little easier than doing it on-prem.
Okay.
Next up is log, metrics, and monitoring. So there have been times when I've been doing incident response where we've seen, something alerting in some threat management system. Oh, there's someone, running sudo. All right. I see the username. I see the IP address. It doesn't really mean much to me. I need to understand, where they came from, what they were doing, the context of those actions. If you don't have robust logging and metrics, then that attack I'm missing a lot of stuff. I'm basically looking at, I'm like a horse with blinders. I see this one little detail, but I don't see the full chain of events. SSH is a more direct one, but you look at things like SQL injection. I've seen SQL injection attacks in Amazon where I see the Apache logs. The problem is, if your Apache instance is behind an elastic load balancer, all I see is the IP address of the load balancer. So I don't actually know where it's coming from the outside internet. So this comes back to logging and metric monitoring. If you don't have robust logging and metrics, then your investigations are just really hamstrung and are kind of shots in the dark.
Do you take your logs from these cloud services and store them locally? Because that was just a cost to storing them in the cloud.
What's nice about it is you can store them, at least in Amazon, into S3 buckets. So there's a few things.
Then you're only paying if you're by access and
exactly.
And things,
So the two big ones are CloudTrail. CloudTrail lets you audit when resources are created, destroyed, or edited in any way from any user.
And that's an Amazon CloudTrail service, right?
Yep.
Okay.
Yep. Next up is VPC flow logs, and these are amazing. I built out, or I actually found someone else that built out a Elastic ELK stack that was really, really cool. So VPC flow logs basically say, this resource talk to this resource. That's it. It's kind of like a NetTab.
Interesting.
Yeah. So
it's kind of like NetFlow, but for your
Amazon
cloud instance. Yeah.
So what's cool is if you have that instance, then I can see, okay, given this exact time frame, Apache was talking to this ELB, but that ELB was talking to these IP addresses. So you can start narrowing it down. Yeah, so flow logs are really, really useful for that. Once you have all that information, though, then you can start attempting to do automatic remediation. So if I say, okay, I can see a massive exfil of 100 megabytes. Okay, that's kind of weird. That's kind of unusual. But more importantly, I can correlate that with the IP address came from outside of America, hit the ELB, hit the varnish cache, hit Apache, hit MySQL, and then when it came on the way back, it's exfilling 100 megabytes coming back out. That to me says that's SQL injection. I don't even have to look at the exact commands run. I can tell just from the behavioral analytics that was probably SQL injection. And they're dumping out the database.
And now you're doing a lot of this analysis manually, or?
Right now, yes, manually.
Okay. A lot of this functionality is what CASBs are providing, right?
CASB?
Cloud Access Security Brokers. More so they're correlating between different cloud providers and doing this similar level of analysis. But I imagine the commercial products are doing some of this analysis as well.
One of the ones.
Which is interesting because we think about SIM as it relates to this cloud problem. It's a very different lens that you're looking through the world of security in.
I'm looking at it more from a developer perspective and an ops perspective, because there's a lot of overlap. Security is not a box in IT. You don't just have this, what do they call it? Not cylinders, but silos. Yeah. So you have a silo of ops, you have a silo of dev, a silo of QA, a silo of security. It's like, no, we're all in the same environment. We're all in the same. We're all in the same resources. We have to understand each other and use each other's tools to really understand and do our jobs better. So that's my little triangle. And the reason I designed it that way is because you can't do any of these in the reverse order. You can't do automatic remediation without resource state management, because you may be undoing someone else's change, but that change was intended, et cetera, et cetera, et cetera. So I kind of designed that triangle. I'll put it up in the show notes. All right, so as far as managing resources correctly, inventory management, one of the tools that I used was called SKEW, S-K-E-W. And I thought about that. In previous assignments, I've worked with 4 or 5 AWS instances, or 4 to 5 AWS accounts. That's pretty easy. I say, give me all your EC2 instances, AIM roles, S3 buckets, et cetera, et cetera, et cetera. That was pretty easy. And I usually, again, I love ELK. But you can use other services. I use reference ELK because that's what I'm familiar with. You could use Sumo Logic, you could use Logarithm, Splunk, et cetera, et cetera, et cetera. Just get it somewhere. So I use SKEW because it basically lets you query, it automatically queries for you all of these resources and dumps it out as JSON. And that's great. So you just say, okay, once every 24 hours, or if you want to be really ambitious, once an hour, query all of the resources and dump that out into my dashboard. And for me, I usually look at what has changed over time. So most companies were increasing the number of resources we use over time. All right, that looks great. But do we see a spike? So for hackers in the AWS account, then you're going to see a spike of resources. Other times, you're going to see unusually new accounts. So you may see accounts that you don't recognize. Accounts created in foreign countries, Eastern Europe, Asia, et cetera, et cetera. So it's like, okay, if it's an American business, why are we seeing someone in Brazil or South Africa creating new user accounts in the IAM roles.
You're taking the logs from AWS,
Yeah.
putting them through an elk stack, and
Yep.
doing this type of analysis. Now, is this code open source, or did you?
I haven't open sourced this yet. I'm working on it.
Okay.
But I'm just saying, like, this is generally how you want to try and do this. Next up is tracking all the state. And you really want to know every little detail of your resources. So obviously the cloud resources, in AWS, your security groups, the OS versions. It's interesting when you look in large organizations, they may be mostly saying, oh, we're a Red Hat shop. And you do inventory management, and you find a cluster of Ubuntu servers.
Right.
And you're like, what's that? Or, you're a Linux shop, and you find a cluster of Windows servers. Like, what's that? So, that's kind of an interesting thing to look at. System users, what are the users within each of the servers? Are these system users that we recognize and know about? The installed packages. Do we have any servers? I usually look at the outliers, which was at your B-Sides presentation, and John mentioned that as well. Look for the outliers. If you see one package that's running on 90% of your fleet, that's probably normal. But if you've had 10 servers that's running one package, what's going on with those 10 servers? That's probably unusual.
The other thing I like to look at, and there is a Nessus plugin that looks for this too. It queries the system, it looks at the installed packages, it looks at the running processes, and it says this running process is not associated with an installed package. This was installed from source or whatever, just some other process.
Yep.
I think that's a great thing to look at as well.
Yeah, look at fundamentally just looking at outliers of any kind. And so the various contexts, OS versions, system users, packages, like you mentioned, running services, looking at service configurations. If you find a service configuration that's kind of out of whack, well, why is that? If our fleet is meant to be fairly consistent, why is that one or two servers configured in a different way? Is that a mistake? Was it not updated correctly? There could be many scenarios for that. Also, too, is keeping track of all the code that's being deployed. If you have code that's being deployed you don't know about, well, where'd that code come from? Could have been an abandoned project.
Right.
Next up is keeping track of network connections. If you see, really weird ports that you're unfamiliar with. So sometimes, I've done this. You scan the network, you get a sense of all the network connections. You suddenly start finding things like StatsD or Graphite or, a monitoring service. And you're like, didn't realize we use that. What's that? And they're like, oh, that's one of the old legacy systems. It's like, oh, okay. Is that still in use? Well, actually, no. So you can find those kind of things when you do inventory management. It's kind of like kicking over the logs within an environment. You're going to find a lot of creepy crawlies.
Yep.
All right, once you get that, once you get a sense of, again, the baseline, then you can start ensuring state. And state's really important because state is what is the state of the system. Like, how are things configured? What is the baseline? And you can start trying to prevent out-of-band changes. Because when you have a large environment with hundreds of developers, hundreds of sysadmins, they're going to make changes, sometimes out-of-band in a way that's not been recorded anywhere. And it could be good for
Never
bad.
done that.
No, it never happened. No one would ever open up port 80 to the world without authentication. That would never happen.
Never.
That brings us to the next. So what are the current options for deploying AWS resources? The quick and easy one, obviously, is the web interface for Amazon. That clearly does not scale. You can't have an intern clicking every little button for you all day. Not going to work. I mean, you can try.
You could. But
You could try. AWS CLI, one of my personal favorite tools. That does not scale. I tried making it scale one time about 3 years ago. Doesn't scale because AWS CLI is fundamentally used with bash scripts. So you think of that, would you really want to build your entire enterprise infrastructure with bash scripts? Probably not.
No.
Don't do that.
No.
Don't do that. Next up, which is an interesting one, which I have seen happen before, is using the AWS SDK. So what that is, it's a language bridge from things like Java, Ruby, PHP, Python, et cetera, that allows you to programmatically create resources. And it sounds like a good idea. If you're a Ruby shop, use the Ruby AWS SDK to deploy resources. If you're a Java shop, use the Java AWS SDK. The catch about that is you're not actually tracking state. You're creating resources, but you're not state tracking. So bit of a slippery slope on that one. Now you have services that most people are familiar with, Chef, Puppet, and Ansible. The catch with those services is that, or those tools, is that they don't support all of the AWS resources. They support most of the core ones like EC2 instances, AIM roles, etc. They don't support some of the newer things like Kinesis, Kafka, Lambda.
Oh, I see.
So you could use them in a pinch, but they don't support everything. Now, what does support everything? You know, I've never used it, but a lot of my enterprise friends have. I can say that now. Yeah, enterprise friends. I have enterprise friends. ServiceNow.
Oh, interesting.
Yeah, all of my friends who work at large corporations in Boston use ServiceNow. They love it, but they always say, yeah, it's a multi-million
Use
dollar.
ServiceNow to manage their all of their cloud
All of them.
resources. Yeah.
And it works, and they love it. The catch is it's a multi-million dollar contract.
Oh, yeah.
So
Yeah,
that's a
but
pretty big barrier.
if you're ServiceNow has a lot of functionality.
It is, yeah.
Yeah.
So I've heard amazing things about it, but ServiceNow is pretty big. The next up thing, which is native to Amazon, is CloudFormation. Now, CloudFormation is pretty cool. It's it's good and bad. It's basically a massive JSON document that you say. Well, the other way is Elastic Beanstalk. Elastic Beanstalk is really cool, but it's really, really limited to like web stacks, like really specific. So if you want to do really specific things with like making a web app, Elastic Beanstalk is great for that. But if you want to use every resource within Amazon, which is most of us do, CloudFormation can do that. The catch is it has a lot of limitations. One of the limitations is that you're using a massive JSON blob. Granted, they have an online builder, like it's all GUI based, which is kind of cool, but it's kind of janky. The catch is the size of that document can only be 50,000 kilobytes. So it's not a very big document. Granted, though, you can kind of chain them together, but you get into other limitations. I think one of them was you can only pass in 64 parameters to sub-documents. So you start hitting some really weird resource limits when you start actually trying to network and chain these things together. My personal favorite tool is called Terraform. So this is from HashiCorp, which also makes Vagrant and Packer.
Yep.
So it's totally open source. It's now 3 years old as of this month. So when I use tools, I don't like to use new tools. I generally say, unless the tool is 3 years old, it's not mature.
Right.
Rule of thumb. But now they're 3 years old as of like last week. So I'm pretty happy about that. So I'm going to get into what Terraform does, just to give you a sense of how it operates and why it is a good product. So first off, it's idempotent, which is a really big phrase in DevOps if you're using Chef, Puppet,
Sounds like a really big word.
Idempotent. Idempotent. It's basically a mathematical idea. So imagine you have a function that says 2 plus 2. So we'll do x plus 2. So you pass in 3, comes out 5. Pass in 4, comes out 6. But the most importantly about idempotency.
Wow, that's a...
Idempotency. You can be idempotent.
You didn't plan to say that, did you?
I didn't even plan on that one. Sometimes you can be idempotent, but man, that idempotency.
I'm good. You know what, though? We're good with that math because we had the WordPress kind of like CAPTCHA turned on, and it asked you basic math questions.
There you go.
And due to a caching issue, it was asking us those like over and over and over again, like almost on an infinite loop. So Mark and I are awesome at like 5 plus 4, like 9. Like awesome at that stuff now.
Got it down. The cool thing about idempotency is it comes back to functional mathematics and programming, which is that if you call a given function, math or otherwise, you'll always get the same result. That's all it means. If you call 3 plus 2, it'll always be 5. That's it. So you apply that concept to infrastructure. If I apply these changes to Amazon resources, they'll always come out the same. And this is a way of doing, you have imperative versus declarative programming. This is declarative programming versus imperative. When you're running things like Python, you're doing imperative programming. Instead, with declarative, you're more or less describing the state that you want it to be in. And you can keep applying it over and over and over again, get the same result. So it's a really interesting kind of like change of mindset. Next up is it has a state file. The state file basically stores the state, like what has been changed, what is the current state of it. But it stores it outside of Amazon. And that's this local database effectively. Next up, which is really cool, a really neat feature, it can do offline diffs. Because you have that state file locally, you can say, oh, I've made some changes to my configuration. Terraform can be offline and actually calculate what needs to be changed without having to directly talk to Amazon, which is a really nice feature. I've tried this one time intentionally. I was in the middle of applying a state change, and I turned off my Wi-Fi. And what's really cool, I turned it back on, and it worked. So tell me how many tools can do that.
That's pretty cool.
Like you can break the connection midway through, and it just works. Yeah, so that was pretty awesome. What's really cool, too, it supports multiple cloud providers. Huge list. It's ridiculous. It supports like 90 cloud providers. Aside from AWS, it supports Azure, Google, Rackspace. I didn't even realize that CenturyLink, the ISP, actually has a cloud service. Yeah, go figure. It supports Dyn DNS, like all the major cloud providers and service providers, I should say, it supports. So you can create resources in all of them. Provisioners, so when you actually make a virtual machine. Unfortunately, right now, it only natively supports Chef. Fair enough, whatever, enterprise. But you can still use Ansible and Puppet. You just have to use it on the command line. So a little different, but still can be used. Next up part, and this is interesting, this is how Terraform makes money, is you have multiple backends. The backends are how you store the state. So I mentioned the idea of having a local state. You think about that. If you and I are working on a project, well, I have a state file, and you have a state file, but are they in sync? So yeah, you can put the state file on GitHub, but that's really tedious. You're constantly pulling that file.
Pushing, yeah.
Yeah.
Well, not in GitHub. Are you pushing?
Yeah. It's just push-pull. It's like having a local state file works fine for like a little mini project, but when you're working in a team, you need to have the idea of a remote state file. Now, they have one where you can serve it inside an S3 bucket, which works out great. But again, when you start scaling things out to 1,000+ servers, you can't be pulling down a 100 megabyte state file. It doesn't scale very well. And this is where Terraform makes their money. With Terraform Enterprise, they'll host your state file for you in a super fast, giving you 10 megabyte download kind of service. That's how they make their money. They intentionally design the system to not allow you to share state files effectively at scale, which is fine. So there's that. Also, another fun project to look into is Segment Stack, which is a really well-built out AWS stack service. It includes, elastic IPs, load balancers, HTTP caches, web layers, RDS, CloudWatch, like every little Amazon service you can think of. They designed a Terraform script to deploy all of these for you. And I'm starting to play with this more often. It's pretty fun. Now, everything I just mentioned is about building everything around the EC2 virtual machines. Terraform by itself can't really build virtual machines. So, fair enough. So you shouldn't think of Terraform as like the end-all be-all tool. It's not. It allows you to build Amazon resources outside of EC2. So it builds all the other stuff, the other 90%. Now, when I do these things, I use Packer. And Packer allows you to build AMIs. You can reuse existing AMIs, which I like to do because Amazon, as I mentioned earlier, has Amazon optimized Linux instances. They have something called HVM, which I believe is hypervisor virtual machines. And basically, they're optimized for their specific type of Zen hypervisor. So I use that as the base image, and then I do everything else on top of that. So Packer lets you do that. And you can also use multiple provisioners. So again, you can use Chef, Puppet, Ansible. So what I'll do is I'll use a combination of Terraform and Packer. Terraform will set up everything else, and then Packer will create my custom AMIs. Admittedly, though, Docker's a little easier to use than that, but still, really good tool. And that's my little rundown of Terraform.
So just quickly wrapping up, you had something about building AMIs and scaling up very quickly because we're running short on time.
Yep, so talk about Packer. You know what? I'll skip over the scaling up section.
Okay.
That comes down to
all your links are in there, which is awesome.
Yeah.
Everything you talked about is in the show notes. Yep. It'll be in the blog post for this segment. So
yeah, and again, too, Terraform is open source. It is free to use, but if you want to do it at scale, you're going to pay some money, and I think that's fair.
Awesome. Thank you so much, Apollo.
Thanks for having me.
Thank you, everyone, for listening and watching Enterprise Security Weekly. That will conclude this episode. We'll see everyone next week. Thanks for listening and watching.